Okay, so the first one is just identities involving double angle. It might help us to remind up here, what's sine of 2x equal to, you remember? Okay.
Sine squared.
Okay.
2 cosine x sine x.
Sine 2x equals sine x plus x, yeah? What's sine of a plus b?
Sine x.
Sine x cosine x plus cosine x sine x. Good job, Gigi. So it is?
What I said, 2 sine x cosine x.
Okay, so it is 2 sine x cosine x. What is, or what are the three forms of cosine to x?
Cosine squared.
Cosine squared minus
1.
sine
Sine squared.
squared, or 2 cosine squared minus 1, or
2 sine squared.
1 minus 2 sine. Okay, so you're going to need to use those in the context of identities. It's not very hard. On the first one, we could either work the left or the right. You don't always have to work the left side. It's up to you. What do you want to work, the left or the right? The right?
I always like working the left.
Let's go with the
No, the left's always
Okay. I'll go with the seniors. Seniors, what do you say?
left.
Left. Left it is. What can you do to the left?
Distribute, or like take it out and distribute.
Distribute or FOIL it out. That's true. So what do you get when you FOIL out sine plus cosine?
It's sine x plus
Sine squared plus cos plus sine cosine how many times?
2.
Yeah, there's 2. The OA in FOIL is 2 sine x cosine x plus cosine squared. Do you agree? Okay. What should we do then?
That equals that.
That equals that. These together equal 1
And
plus 2 sine of x cosine of x. That's one identity used. And then,
you're done. Sine x.
not done. That is equal to equals sine of 2x. Then, alright, you with me?
Yeah.
Cool. Alright, try the next one on your own. See how it goes.
We just sort of all here pretty much.
Yeah, it's just like identity. It's really combining two things you already know. Double angle identities with identities.
Okay.
Ready? What'd you do first? Cyrus, what'd you do? Leah, what'd you do? Sorry, that was a gym teacher.
I factored the top into cosine squared x minus sine squared x times cosine squared x plus sine squared x.
Okay. Oops. I get the idea. So much writing. Devin, what did you do after that?
I changed the cosine squared x plus sine squared x to cosine.
The plus one to cosine 2x or the minus one?
The minus one.
The minus one. Okay, gotcha. Cosine of 2x, the subtraction one is equal to cosine of 2x. It's, I don't know, is it? I think it'd be roughly the same either way. Actually, isn't this less writing than that?
No, because if you change the bottom to cosine squared x minus sine squared x, it cancels.
Yeah, but this cancels too.
Oh,
And this is less writing, am I right? Okay, what else do we need to do?
That equals cancel.
That equals, that needs to be replaced by 1.
If you cancel and replace it by 1.
Come on now.
No.
Okay, you keep on changing the rules.
Yeah, we always like.
What did I say? You can cancel
You
and make a
cancel.
You
substitution.
said algebra
It's
steps
not one
are
Don't count.
don't count.
Okay, you're right.
Canceling.
You're right. But according to what I say, if you canceled and did an identity, you would be. Okay? Okay.
Just substitutions have to be mixed up.
Substitutions are one substitution at a time. All right. Proof.
No.
Prove This truly is the area of the triangle. Okay, what is the area of the triangle way that you used to? Base times height divided by 2. Okay, do you agree that that is true? Okay, now let's show where this idea comes from, because our idea comes from that idea with trig. So, say you were going to find the area of this. You would need to find the height, wouldn't you? You have the base, but you don't know the height, right? So how would you find the height? Look right here.
It's a 90-degree angle.
Okay, so we could use right triangle trig. What's this angle here? Big C, yeah, because it's across from side C, yeah? Right, so use trig to tell me how you would find height. Would you use cosine? Why not? You don't know this adjacent side. It's part of B, but you don't know how much, right? So you wouldn't use you wouldn't use cosine. What would you? Sine. Okay, so let's use sine. Sine what? Sine of big C equals H over A, yeah? So H is, so if I solve for H, we're finding H.
A sine C.
A sine C, do you agree?
Yes.
Now, if our area is base height divided by 2, and I put in that height, then area is base times A sine C over 2, and isn't that then just housekeeping at that point? 1/2. Can I switch the order of B to A? A to B? Multiplication's not commutative. I can't switch the order of B to A to B. Yes, you can. Okay, so, boom, that's where it comes from. The area just comes from base height divided by 2 with a little trig from it. You with me? Okay. All right. Let's say we prove the law of sines. Now, there are actually a lot of ways to do this. I'm giving you a hint on one way, but you could also talk about finding H 2 ways. Let's just go with what I have here. Do you agree that I could use that formula to find area based on any pair of sides in the angle between them? So I could do, if I knew A and B and the angle between them, I could find the area that way, right? Do you agree? But if I knew B and C and the angle between them, what would the angle between them be? Angle A, do you agree? Well, I could, it wouldn't matter, A, B, C, as long as I have two sides in the angle between them, area of a triangle is equal to area of a triangle. Do you agree? All right. Now, if I start with that truth, that the area of the triangle would be the same either way I found it, how could you take that and develop the law of sines? What's one thing you could do, easy thing you could do? I want to get from here to here. Let's really just clean up. Let's dump the 1/2. Do you agree that I could multiply both sides by 2 or divide out the half? And that's gone. Okay, I just divided out the half. Get rid of B. I could divide out of B. If I divide out of B, I have A sine C equals C sine A. Divide out B. Have in mind where I'm trying to go to. What can I do then? Divide both sides by sines. Let's do it at one step at a time, shall we? Or should we multiply both sides by 1 over sine A sine C? What do you want to do?
Just do it by sine.
Okay, so let's do it. You can't divide sine with nothing in it. It has to be sine of something. So let's say we divide by sine of C. Doesn't that give me A equals C over sine of A over sine of C? Oops, my law of sines is going to be backwards. But then divide by sine of A. It's actually the same. Divide by sine of A, yeah? And I get A is to sine of A as C is to sine of C. And you could do the same if you want sine of b is to b. We don't need to do that also if it's b is to sine of b. Are you with me? Okay. That's one way to prove it. There's actually a couple ways to prove it. All right. Similar triangles. This is review all the way back to pre-algebra with you. This does have a little bit of notation. First of all, similar triangles. Remember, similar triangles have the same what? Angles, and therefore the same shape. What makes a triangle look like, different than the other is the angles. The sides obviously could be different as well, but similar triangles have the same shape, so because they have the same angles. So the corresponding angles are, what's the geometry word for equal? Congruent. If corresponding angles are congruent, then corresponding sides are
Similar.
not similar, not equal, not proportional. Proportion. They are proportion. Which is to say the ratio of side A, B is to the side ratio of side A prime to B prime. This is read as prime. Also, notation. Would you write this squiggly? That is similar. Here we would say triangle ABC is similar to triangle A prime, B prime, C prime. Follow? You with me? There's, besides proportional, you could say there's a constant of proportionality or a scale factor. All those are different words used in different texts. I don't want you to go to college and they say constant of proportionality and it mean nothing. Okay, it's a scale factor. You might say this is half as much going this way or twice as much going this way. All right. Closure, would you, on some whiteboard or notes or whatever, I got some scratch paper here if you like. There's this slide and another slide. They should be hopefully pretty easy. I hope. Does anybody want some scratch? Okay.
Yes, that was perfect.
There it is. It's
No.
atrocious.
Remember this time again?
Okay. You're welcome. Do I need to get you yesterday's set on? Or,
I have yesterday's set, but I have to grade level.
okay. Alright. So you have How is your sister, by the way? Good. Okay. Sorry. All right. So you said you have yesterday, so it's Hannah give it to you or something? Or you need it? Oh, okay, cool. So you just need this set to get it. All right. I don't know what this bad boy. Need another minute or you're good to go?
Oh, more time. No, I'm not actually. I got like confused.
Okay.
I'm not actually confused. I'm just
Actually,
no, I'm not confused. I just was having trouble connecting the dots.
okay.
I can connect the dots.
All right. So, did I give you enough? It's up there. I told you that the triangles are similar. Sorry, first of all. If you don't know the triangles are similar, then you can do absolutely nothing.
Wait, why not?
Because if I gave you two triangles that had nothing to do with each other, then I could say nothing between the two. So although they kind of look similar, without being actually told they are similar, you really can do nothing.
Can't you just like rearrange the law of cosine the side and solve for x instead of c or the angle?
Oh, So is that what are you guys doing like last time? Oh, I think the implication is they want you to use similar triangles there. Sorry. So let's just go through it, shall we? Do you agree that because the triangles are similar, the sides are proportional?
Yeah.
However, there's obviously some kind of reflection going on. And so make sure you compare the correct sides. 15 is to 6 as
24 is to X.
24 is to X as Y is to 18, yeah? Okay. So if you take 2 at a time, obviously you don't solve all 3 at a time. Wouldn't you agree that by cross product you get 15x equals 6 times 24, and therefore x is 6 times 24 over 15, or 18, did you say? 2, 5, 48 fifths, I agree. 48 fifths for x. Do you agree? Okay, now find y if you haven't already done so. And while, if you're done finding y, because you're super smart, then I would like you to consider this problem, which other textbooks would write. Sometimes you'll see that. Okay. What is the scale factor going left to right? In other words, what would you multiply the left side by to get the right side? Here's where you should look.
2 point something.
Right. Would you multiply by 6/15 or 15/6 going left to right?
15/6.
Do you want to get bigger or smaller going left to right?
Smaller.
Smaller. So which would make it smaller? 6/15 or 15/6? 6/15. The scale factor left to right is 6/15. What's the scale factor right to left?
15/6.
15/6. Okay. That's also called the constant of proportion. What else? What?
How do you find E?
Which one?
D, the angle.
40 plus 60.
Inside the right triangle.
Oh, good question. How do you?
40 plus 60.
What does this angle have to be? 60. So this has to be, because these similar triangles have congruent angles. So that has to be 60, and therefore Z has to be 80, yeah? And did you get side Y? What's Y?
45.
45. Okay, cool. Feels like this is going okay. You're good, you think? Allie? So easy, you're good? Okay.
No, I want to be good at math.
Yeah. You are. Ready?
I'm gonna put my phone down.
I don't actually.
No,
I 100% agree. 100%.
I was assuming I was going to.
You're a real fireball. At home when I'm playing basketball. I usually, like, if we're playing one-on-one, I have to start like 30 points ahead of them. It's hard. She's pretty good. She used to start it and
My cousin is frozen on the ground. And so I have a bunch of dried up sponges on the ground.
yeah, like
That's really good basketball.